What overcurrent settings improve renewable energy system stability? Imagine a power grid that smoothly handles solar panels and wind turbines without hiccups. That's where overcurrent protection plays a big role. It's like a safety net that catches faults before they cause chaos. In renewable energy systems, especially those with distributed sources like solar and wind, setting the right overcurrent parameters is key to keeping everything stable. Overcurrent protection devices, such as relays and fuses, are designed to trip or disconnect circuits when currents go beyond safe limits. They prevent damage to equipment and help keep the whole system running smoothly. The main settings to focus on are the pickup current, which is the minimum current needed to trigger protection, the time delay, which controls how quickly the device responds, and how these devices coordinate with each other across the network. Renewable energy sources, especially inverter-based systems like solar photovoltaic panels and wind turbines, behave differently during faults compared to traditional generators. They tend to produce much lower fault currents, which means if the protection settings are not adjusted, faults might go unnoticed. That's why setting the pickup current lower can help detect these smaller fault currents. The time delay setting is also important. It determines how long the protection device waits before disconnecting the circuit after detecting an overcurrent. Proper coordination ensures that only the faulty section is isolated, not the entire system. This prevents unnecessary outages and maintains stability. In systems with multiple sources, such as solar and wind combined with storage batteries, protection devices need to work together. They should be coordinated so that the device closest to the fault trips first. This selective action keeps the rest of the system running smoothly. Directional overcurrent protection is another useful feature. It helps in systems where power flows in both directions, like in distributed generation setups. These relays can tell if current is flowing towards or away from the source, making sure the right device trips during a fault. Some modern protection systems are adaptive. They can change their settings based on real-time conditions. This is especially helpful in renewable systems where generation and load can change quickly. Adaptive settings help keep faults detected and isolated, even during rapid changes. In solar photovoltaic systems, overcurrent settings need to be more sensitive because inverters produce lower fault currents. Using more sensitive relays or adjusting pickup and delay times ensures faults are caught early. Wind farms with many turbines requiring careful coordination of protection devices. If one turbine detects a fault, it should trip without shutting down the entire farm. Proper overcurrent settings make this possible. Hybrid systems that combine solar, wind, and storage benefit from adaptive and directional protection. These settings help maintain system stability during fluctuating generation and load conditions. In summary, choosing the right overcurrent settings is vital for renewable energy system stability. Adjustments to pickup current, time delay, coordination, and directional features ensure faults are detected accurately and isolated quickly. Tailoring these settings to the unique traits of renewable sources helps keep the power flowing smoothly and safely.